Hello. In this lesson, we're going to be talking about functions. We have a lot of definitions to work with today. So let's take a look at it. The first one is input. Input is the value that's put into a function machine. And I'm going to tell you more about this concept of a function machine in just a second. The output is the result after applying a rule. And that rule is whatever is internal to our function machine. And we'll go into detail a little bit more on that on future slides. A relation is a set of inputs with corresponding outputs. It's anytime you say, I put in this and I get this out. Now, a function is a special type of relation. Okay, it's still a relation where with exactly one output for each input. I'll say that again. There's exactly one output for each input. All right, and that's what we're going to be spending most of our time today discussing. All right, domain is the set of all inputs, and range is the set of all outputs. Now, the word set came up a lot of times here, so I want to introduce you to a symbol that we're going to use here, and they're called braces, kind of like those things you might have on your teeth. And if you look at your keyboard, it's the key that if you held down the shift key to do a bracket, okay, it is kind of looks like that. That is called a brace. That's a left one, and that's a right one. Yes, I practiced it a lot to be able to draw it so quickly. I don't expect you to right away be able to create those. But think of it this way. If you collected something and you put together a set, you would want to make sure to display it or keep it in a particular way. Maybe you collect baseball cards and you have a notebook with card holders. Or maybe you collect action figures and you keep them on display somewhere, but you store your set, your collection, in a special way. Well, in math, that special way is braces. Okay? So here is the function machine I created. I like to go with the idea of a vending machine. Okay, vending machines have all the properties that we need in order to talk about functions. Vending machine has buttons. That would be the input, the button that you press. And then there's a section down here where an output would come out based on what you push. So let's go ahead and look at the first one. Let's say I pushed a yellow button. Well, the yellow button gave me the yellow item. Okay? That could be anything. That could be something that's yellow. I don't know. I don't want to say anything proprietary, but the whole idea there is we pushed yellow and we got an input that we expected. If we push the green one, we can expect the green item to come out. You push the gray one, you think it's gray. Now, look at what happens over here, though. We have a blue button. If we press the blue button, we get something blue. But there's another blue button right below it, and it still gives you something blue. Isn't that the way a vending machine works? Very often, depending on the company that produced it, you probably have one button for certain things. But then for the really popular item, the thing that the company thinks that most people are going to want to buy, there might be 2, 3, or 4 buttons that all give you the same thing. That's okay. As long as every input has exactly one output, you're okay. Problems start arising if an input could have more than one output. For instance, we press this last button, and instead of getting a blue, we got a yellow. Or maybe we don't know what's going to happen. Could you imagine going to a vending machine where it had all the same 4 types of drinks or items in it, but it was just one big button with a question mark on it. And you're expected to feed it $1. Your input is always the same thing, that big gray question mark button, but you might get the yellow thing. You might get the blue thing. You might get the gray one, or even a black one. We haven't even seen that before. Would you be happy about that? Would you really want to go and get something from that particular vending machine where you're going to push a button and you don't know what you're going to get? It'd be fun for a little while, but if you have to pay $1 like you do in most vending machines, or $1.50, would you really be interested in that? I wouldn't be. You would say the machine is broken or it's not functioning correctly. And that's the whole idea behind a function. So let's take a look. This got a little bit squirrely here, but it still works okay. Is this a function? This is called a mapping. And we're saying that the number 1 goes to 7. This was connected originally to the number 2, going to 12. The number 3, which is the next bar, goes up to 7. And then the number 4, which is the last one, came over to 12. More than one thing went to 7, but did every input only go to one place? Yes. So is this a function? Yes, indeed. It is a function. So let's take a look at this one. And same kind of thing happened here. But the number 1 goes to the number 7. I'll skip down here to this bottom bit. That goes with the number 3, which goes to the number 12. But do you see this one here? The number 2 has 2 arrows coming from it. So the number 2 could go 2 different places. Is that okay based on what we know about functions? No, it's not okay. The whole point of a function is you know what's going to happen. Anytime you put something in, you know what's going to come out. You can have different inputs give you the same output. But as soon as you don't know what's going to happen for certain, it's no longer a function. So another way to represent is an input-output table. Here's a figure that I put together. It just, the first figure has 1 dot. The second figure has 3. The third figure 6, and so on and so forth. If we want to make an input-output table where the input is in and the output is the number t, we could get a table that looks kind of like this, where the input is 1, the first figure has 1 dot, the second figure has 3 dots, the third figure has 6 dots, and so on. So once we have that, is it a function? Well, does each number only go one place? Yes, it does. So we can say yes. So let's bring back some of that vocabulary we talked about also. What is the domain of this function? Do you remember what a domain is? It's the set of all of the inputs. That's these guys right here. So that's 1, 2, 3, 4, 5, and 6. And let's see how well you remember. Is that everything we need to say domain? It's the set of all the inputs? We're missing something. Braces. We've got to put braces around it anytime we talk about the domain. Or, like we'll do on this next slide, the range. That's the set of the outputs. 1, 3, 6, 10, 15, and 21. Those are the numbers. But remember, since we are dealing with a set, we've got to put it in some braces. All right? And since this is math, let's bring it back to some equations here. You can have equations as your functions. In this case, you bicycle 4 miles and decide to ride for 2.5 more at 6 miles per hour. The distance you have traveled, D for distance, after T hours is given by this equation. D equals 4 plus 6T. And then here's the restrictions on what types of things you can put in to this equation. But let's just create a table. I already have one ready to put together. If T is 0, the output is going to be 4 if you don't ride for any hours. If you ride for half an hour, half of 6 is 3 plus 4 is 7. And I went ahead and did some other ones. 1 gives you 10. 1.5 gives you 13. 2 gives you 16. 2.5 gives you 19. And we can put that together in the form of a table. Right here. Here's our inputs T. And our outputs D. Just like we did on the prior one with those figures, the triangular numbers. Well, now that we have a table, there's other things that we can do with it. Some of our later videos are going to talk about graphing. And basically all you need to do if you're going to graph something is go ahead and plot the points. So here is our input axis, which is in this case time. And here's our output axis. And I went ahead and plotted each of those points. And I just drew a line connecting them. And there you go. It is a function. And this is where another little tool called the vertical line test can come into play. The vertical line test is really simple. If you're looking at a graph or a picture, if you draw a vertical line anywhere on the graph, if it only touches the graph in one place, it's a function. If it does it more than one place, it's not. And that introduces the idea of slope for a function that makes a line. It would be the rate of change is the name for that. It's always expressed as a fraction where you're talking about the rise